Hello, geometry students. We're going to be taking a look at translations. Although this says chapter 9, don't worry about that. This section's pretty easy. That's why I'm kind of jumping to it before we hit similarity and trig, which is going to be a little bit more challenging. What's going on here? You're being asked to identify rigid motions and find translation images of figures. So what's that mean? What's a transformation? We go through transformations all the time, but in geometry, what is that like? So a transformation is really when we have a geometric figure of something that's mapped out and we change it whether through the position, the shape, or the size. If you've played dominoes before, you move the dominoes by flipping them, sliding them, or turning them. Each move is a type of transformation. We'll see these done how just moving one domino or one shape, just moving it along does something. We'll also deal with rotation of that. I don't think we see too much of flipping, but that's okay. We have two more things to take note of. The original figure, so for example in this one right here, we say that the original is the pre-image. So before all of these changes, modifications, Botox surgery, plastic surgery, all these things that we do to these figures to move them around, shape them, make them look different, we say that the original is the pre-image and the resulting figure is the image. The first one that we'll learn about in 9.1, a transformation that preserves the distance and the angle measures, is just called a rigid motion. It's really just pushing the shape along to a different section. And I'll be demonstrating this with this example seen here. So I've never moved art in my life. I've never had a moving job, but I'm sure all of the movers out there think of their work just like this, where they may have some shape or some original pre-image. So for example, this one here we'll call the pre-image. And based off of this translation or this rigid motion, given this scenario here, this is a vector, this is saying that we want all of the x coordinates to move 2 units to the left and all of the y coordinates to move 6 units up. So this can be something that's slightly new, but notice that if I were to start with, let's make this convenient, if I was starting with this pre-image here, where the bottom left is 3, 0, and the bottom right is 6, 0, if I were to move all of these units, 2 units to the left, and then 6 units up, notice how this unit here of 3, 0 is now moved to 1, 6, which makes sense because if we take 3 and we deduct 2 from the x coordinate, we're left with 1. Same way, if we were to look at 0, we add 6. 0 plus 6 gets you 6. And so what's interesting is that we do this for all of the coordinates. Although only 2 are highlighted here, we do the same thing for the top left and top right. So it may also make sense that the bottom right would be starting at 6, 0 for the pre-image, but the image would deduct 2, getting 4, adding 6, getting 4, 6, and all of those points fall into place. So let's see what else we can do with this. If we were to maybe make the pre-image a little goofy, it's okay, we're allowed to have that happen. Notice how this top left is 6, 4, but this still retains the same movements that are mentioned here of deducting 2 and moving 6. So this just kind of makes sense to me. I don't think this section's too tough, or this first one at least. Just really look at the translation vector that's given in whatever directions are given. Think about what the image is, think about the pre-image, take care of all of the shapes and move them along. Pretty easy.